So, let's dive into one of the wildest stories in all of science. It's about a brilliant, absolutely beautiful, and deeply strange equation that led to the discovery of a whole new kind of reality: antimatter. All right, let's get right into it.
Imagine this, it's 1928. A young physicist presents his latest work, and that's the reaction from Werner Heisenberg, one of the giants of quantum mechanics. And he wasn't alone. Another legend, Wolfgang Pauli, supposedly got so upset he quit physics to go write a novel. No joke.
So you have to ask, what on earth could a 25-year-old have possibly said to send the world's greatest minds into a total tailspin? What idea was so profoundly disturbing?
Well, that young man was Paul Dirac, and what he was presenting was his brand new equation for the electron. And his audience was horrified. Not because his math was wrong, oh no, but because of what it implied about the very fabric of our universe.
And right there, that's the culprit. His incredibly elegant equation spat out answers that described a particle with negative energy. Now, this wasn't just a little weird. To everyone back then, it seemed physically impossible. It was a complete deal-breaker for any serious theory.
Okay, so to understand why Dirac even went down this rabbit hole, we need to back up a little. See, in the 1920s, physics had this massive problem. You had two magnificent theories that described the universe, but they just would not talk to each other.
So, in one corner, you've got Einstein's relativity. It's perfect for describing things moving incredibly fast, like near the speed of light. And in the other corner, you have Schrödinger's quantum mechanics, which describes the bizarre, tiny world of atoms and electrons. But here's the problem. What happens when you have a tiny thing moving really, really fast? Yeah, both theories just completely fall apart.
And that was the holy grail. Physics needed a single, unified equation that could handle an electron, which is obviously tiny, even when it's whipping around at nearly the speed of light. This was the massive puzzle that our young protagonist, Paul Dirac, decided he was going to solve.
And this is where Paul Dirac enters the story. And you have to understand, he wasn't just a physicist. He was kind of a mathematical artist. For him, the path to truth wasn't just about experiments. It was about finding pure mathematical beauty. I mean, his colleagues literally nicknamed him the strangest man. He was so legendarily quiet that they invented a unit of measurement called a Dirac, which meant 1 word per hour. But this quiet man had this radical belief. If an equation was beautiful, if it was elegant, it had to be right, even if it seemed to fly in the face of reality.
So Dirac saw that earlier attempts to combine the two theories led to just ridiculous results, like negative probabilities, which make no sense. So he took a totally different route. He realized ordinary numbers just weren't going to cut it. He needed a whole different kind of mathematical tool. And this is just pure genius. He made the leap to using these abstract things called 4x4 matrices.
And the result? It was breathtaking. The Dirac equation was everything he wanted. It was symmetrical, it was compact, it was just profoundly beautiful. A true masterpiece. But hiding inside that beautiful math was the very monster that was about to cause such an uproar.
So Dirac has his beautiful equation, and in some ways it worked spectacularly well. But it came with that one tiny little flaw that seemed like it could break the entire universe.
But first, let's talk about what it got right, because this is amazing. It perfectly described high-speed electrons. And get this, completely by accident, the math itself naturally predicted a quantum property called spin, which before this, physicists just kind of had to staple onto their theories. This was a huge, huge win.
But then, there was the negative energy problem. And why was that so bad? Well, think of it like this. If an electron could have negative energy, it would be like a ball on a hill with no bottom. There'd be nothing to stop it from falling into lower and lower energy states forever, spitting out an infinite amount of energy along the way. The entire universe should be completely unstable. It was, as Dirac himself put it, physically nonsense.
So you see the paradox, right? The very same beautiful math that brilliantly predicted electron spin also demanded that these impossible negative energy states had to exist. His solution had brought back physics' most terrifying ghost.
For 3 years, the entire physics world just wrestled with this. Most figured, well, the equation must be wrong, but not Dirac. Sticking to his belief in mathematical beauty, he just refused to give up. He decided the flaw wasn't a flaw at all. It was a prediction. So in 1931, he made this incredibly bold proposal.
He wrote that maybe, just maybe, these weird solutions were describing an anti-electron, a new kind of particle unknown to experimental physics.
And what was this anti-electron? Well, it would be a perfect mirror image. It would have the exact same mass as a regular electron, but the exact opposite electrical charge, so a positive charge. He was literally proposing a perfect counterpart to the electron, an antimatter particle. Think about that, a whole new particle, predicted purely from a beautiful equation that almost everyone else thought was broken. It was an absolutely extraordinary claim, and, as it turns out, it didn't have to wait long for some extraordinary proof.
And what's really amazing is just how fast this all happened. So 1928, the theory is called the saddest chapter. 1931, Dirac makes his wild prediction. And then, just 1 year later, in 1932, an American physicist named Carl Anderson is looking at the tracks left behind by cosmic rays, and he finds something weird.
He saw a particle that curved in his experiment's magnetic field, just like an electron. So it had the same mass, but it curved in the opposite direction. That meant it had a positive charge. He had accidentally discovered Dirac's anti-electron, which he called the positron. The beautiful equation wasn't wrong at all, it was prophetic.
And that discovery changed absolutely everything. It wasn't just about one anti-electron. No, Dirac had stumbled upon a fundamental symmetry of nature. We now know that every single particle of matter, protons, neutrons, you name it, has a corresponding antiparticle. He had discovered an entire hidden mirror image universe.
And this brings us to one of the biggest, most profound, unanswered questions in all of science. You see, our best theories tell us the Big Bang should have created matter and antimatter in equal amounts. But here's the thing. When they meet, they annihilate each other in a flash of pure energy. So why is there anything left? Why is our entire universe made of matter? Why are we even here to ask the question? That is the profound legacy of Dirac's beautiful and once terrifying equation.